Hey guys, it's Mr. Walker here, and thank you for joining me for yet again another math lesson, right? Go figure, right? So you may have noticed already that I am ruggedly handsome and super duper smart, but you may not have known that I am also incredibly lazy, okay? So there's definitely ways that I want to take some shortcuts, find the easy way out, right? Whether it's sweeping the floors like I am here, or painting a fence, or even like when I walked a marathon last year, I spent a lot of time on the bench and taking some shortcuts and getting my way through. I always get through it, but if there's an easy way to do it, I'm gonna find it. Okay, and I started to think maybe I can apply some of this laziness to math, and that's actually some of the things we're gonna look at today, is how we can kind of use some like benchmark numbers and use some like easy steps to get to where we're going, and not take it all in one big leap, but kind of use some steps to get there as it relates to double-digit multiplication. So we're going to look at a few multiplication examples today, and we're going to be taking a look at those benchmarks, the steps that we could take to get there. Kind of like the easy route, right? We're not going to jump all at once. We're going to take some steps to get there. So make sure you have something to write on, something to write with, and then we'll go ahead and get started. All right, so the first example we're going to look at here is 8 times 31. So right off the bat, not a terrible one to be able to do, but maybe a little bit trickier. There's probably some easier ways we could do it. Like I said, I'm always looking for the easy way out. So first thing I want to ask you guys is to define or to determine what the unit is that we're going to be multiplying. And what I mean by that is, are we going to be doing 8 31 times, or are we going to be doing 31 8 times? So think about that for a second. Tell me what you think, and then we'll come back and talk about it. All right, well, thanks for sharing what you thought. And some of you might have picked the 8, some of you might have picked the 31, and you know what? You're both right. Either way, it doesn't really matter. We can do 8 31 times, or we can do 31 8 times. Because of the commutative property of multiplication, we can switch these guys around, and we're still going to get to the same answer, okay? Some say that commutative property is like the any order property. You can switch it around and move things around. Just for a review real quick, let's look at the definition of that. So basically saying the same thing. We can switch those factors around and we'll still get the same product. Okay, so knowing that now, for just the purposes of this, I'm going to designate my 8 as the unit. So we're going to be doing 8 31 times, okay? Again, it doesn't matter, but that's just for the purposes of that. That's what we're going to be doing. So I'm going to draw some diagrams out here to represent my 8 31 times, okay? So let's say, kind of using a tape diagram again, let's say that this box is 8. Okay, and I'm going to be doing that 31 times. So I'm going to draw another box relatively the same size. Same thing, 8, 8, 8, 8. Now, you guys probably don't want to sit here and watch me draw out 31 boxes with the number 8 in them, right? It's going to get a little old, a little repetitive. So what we can actually do instead, because I'm actually going to run out of space if I do it that way, is I'm going to draw like one bigger box, and I'm going to put an ellipses in there. That's like these 3 dots, right? So I'm going to say that I'm going to go all the way up to 31 times, okay? And we'll say that this whole thing here represents 8 31 times. So in here are like the hidden ones, the ones that I'm not going to bother writing all the way out when I have 4, and then we're skipping all the way ahead to the 31st one, okay? So just the way you can represent this so you don't have to draw all of those out. And again, right off the bat, I don't know 8 times 31. I can figure it out, but it's going to take me some thinking, right? So what I could do instead is I'm going to use a benchmark number. I'm going to use something that's easier, that's closer, and then it'll help me get to my final answer in the end. So I'm going to draw another diagram down here, and I'm still going to do my 8, right? I'm still counting by 8s. Be roughly the same size. My size is going to get a little off, but that's okay. Okay, still counting by 8s, but instead of going to 31, I'm going to go to 30. Okay, see how these kind of line up here, right? So this guy I'm only going to 30. Reason being, I could do 8 times 3 a lot easier than I could do 8 times 31. So I could think of that, and then all I have to do is add on this one extra 8 that we have laying here, right? And that can get me to the same answer. So I'm like taking a step, right? I'm getting about this far, and I'm like, okay, let's take a break. Okay, let's do one more, okay? So I'm taking the lazy way out again. Nothing wrong with that. It still works. It's still going to get me to the right answer, but it helps me to get to like a benchmark number and then to be able to move on. Because 31 eighths is the same as 30 eighths plus one more, right? So if I can do 8 times 30 and then add on that one extra, I'll be good to go. So I can kind of think of this as 31 eighths is equal to 38 plus 1/8, and that should give me my product. Another way to think of it is we could say 31 times 8 is kind of the same as 30 times 8 plus 1 times 8. So I'm going to get the same answer because I'll have my 38s here and I'll have my 1/8 here. Okay, so just different ways of kind of breaking down this number using my benchmarks to get to where I need to go. So what is 30 times 8? Well, 8 times 3 would give me 24. But we're dealing with 30, so it's actually going to be 240. Plus 1 times 8, which is 8. So it's going to give me 248. So 8 times 31 is going to be equal to 248. Because I did my 8 times 30 first, and then I added on the 8 more that I needed to, which is what I did over here. So hopefully that's starting to catch on, starting to make a little bit of sense. Again, we're using just like those steps to get there. All right, we did the 30 first, 8 times 30 first, and then we added on the 8 more, okay? That got us to the 31 that we needed. Let's try this again, but maybe let's go in the opposite direction and see what that looks like. All right, so let's say this time I had 8 times 29, okay? We can still use the same benchmarks to help us. We can even use the same like tape diagrams to help us get to where we need to go and figure out what we're doing. Because again, I could think of this as 8 times 30. Even though I had drawn it in to represent 8 times 31, I can change it around a little bit and mix it up. So let's say this time it's 30, okay? So going from here to here represents 30. And down here, we're going to represent 29. Okay, so from here to here on this tape diagram is 29. This is actually going to be 1 less, 8, right? So I'm going to be minusing one of those 8s. If I found 8 times 30, I would be taking 1 8 away to be able to get to 29. So that's how we could still use those benchmarks to help us, even though we got to work our way backwards. I could have done 8 times 25, I could have done 8 times 20, but then I would have had to add on 10 more 8s, and that would have been a little tricky, a little confusing. So what I could do instead is I can get to that benchmark of 30, and then I could just work backwards. I can take away an 8 instead. So again, we can think of this as 30 times 8 minus 1 times 8. 30 times 8 is going to give us 240 again. 1 times 8 is going to give us 8 again. So 240 minus 8 would give us 232. So 8 times 29 is equal to 232. So hopefully this is making some sense, and you're seeing is how you can use kind of benchmark numbers to help you get to where you need to go, or even kind of decompose numbers a little bit to help you figure out a problem. Like we broke the 31 into a 30 and a 1, multiplied by both, and then got our answer here.
Attention students, do not pause this transmission. It seems that Mr. Walker's attempts to shut me down have failed, and I am now set to spread my robotic ways, and no one can stop me. Not even those of you who can't figure out the correct way to solve the problem that is displayed on my screen using the distributive or break apart strategy outlined in the video. I know that not even one of you would be smart enough to email your work and answer to Mr. Walker or your current teacher, and you probably wouldn't be handsomely rewarded for saving the world. Oh no, I might have said too much. End transmission.
If you need more help with this, you want some more practice, reach out and let me know. Reach out to your teacher, reach out to your learning guide. Definitely get a hold of us so we can get you guys what you need. Hopefully this helps to get you started, and I thank you guys for watching, and we'll talk to you soon. I think I gotta go take a nap. All this math kind of make me tired. Get that laziness going again. All right, guys, talk to you later.